For the final two steps of this air pressure activity, we're asked to think a little bit more about our estimate of H space, the height of the edge of the atmosphere, and consider how accurate or inaccurate it might be and how we could improve our estimate. And step 12 actually lets us know that our estimate of about 8 kilometers is quite a low estimate. So what assumptions are we making in that calculation, and which assumptions might not be warranted or might be responsible for the inaccuracy of this estimate? And we're also given a hint, which is, can you explain why it's not gravity's fault? So think about what we might be assuming is the same at the edge of the atmosphere as on the surface of Earth, and whether or not that assumption is really warranted. So looking back to the actual calculation that we did to find H space, two potential assumptions jump out to me. And that is that we're holding both g and rho, the density of air, constant. So we're making the assumption that both of those quantities would be approximately the same at the surface of Earth as they would be at the edge of the atmosphere. So you might be inclined to think that our assumption about gravity is what's at fault for our low estimate, because we know that as we get further away from the Earth, the gravitational acceleration is going to decrease. But actually, at only 8 kilometers off the surface of Earth, the difference in the gravitational acceleration is going to be pretty negligible and not have a huge impact on our estimate. And for context, there are actually places on Earth that are about 8 kilometers above sea level, like Mount Everest. So then if it's not gravity, we want to look towards air density, which also decreases as you go higher up in the atmosphere. And with air density, the difference is not going to be negligible, so that's what's going to have the most impact on why our estimate is so low. So in order to improve our estimate of H space, the height of the edge of the atmosphere, we would need to somehow account for the way that air density changes as you go up higher in the atmosphere. And one way to do that would be to collect a lot more data over a wider range of heights, and then use that data to make a new and improved model that can take into consideration the way that air density changes with height.